Okay, dear students, let's come to the next topic of electronics, and that is diodes. So, first of all, what is a diode? Diode is an electronic component which permits the flow of current in one direction only. So, basically, it does not permit the current to flow in opposite direction. Today diodes are made up of semiconductor material, therefore they are often called semiconductor diodes or crystal diodes. Now why we use the diode? There are many applications of diodes, but the most important application is rectification. We will see in the next few slides what is meant by rectification. So first of all, diodes are used for rectification. They are also used in electrical meters for their protection, and they are also used in wave shaping circuits. Diodes in the form of LEDs are normally used in display, and we have seen these in different colors in different applications. Now, diodes are semiconductor devices. They are made either of the silicon or germanium. There are four broader types of the diodes: PN junction diodes, Zener diodes, light emitting diodes, and photodiodes. So coming to the first one, PN junction diode. Now why it is called PN junction diode? Because this diode is made up of the combination of two materials, that is P type and N type. P is for positive, N is for negative. So this PN junction diode works in forward biasing, that is, anode is connected to the positive terminal and cathode is connected to the negative terminal. Now if it is connected in reverse, which is known as reverse biased, this diode will not permit the electric current to flow through it. So it means that it can only be connected in one direction, and it only works in the forward bias. Now this is the symbol for a diode. This is the anode side and this is the cathode side, and this arrow indicates that the current is flowing in this direction from anode to cathode. So if it is connected in the reverse direction, the current will not flow. In practical, this is the real life image of any diode, and this line, white line, is similar to this line. So this area is the anode, and the point where this white line is connected, this is the cathode line, which indicates the current flow to be connected in only one direction. How can we recognize? As I have told you, there is a silver band on one side of the diode, which is the cathode or negative terminal of the diode, and the other side is the positive or anode side. Next type of the diode is the Zener diode. The Zener diode works in reverse bias. This is the symbol for the Zener diode. We can see that instead of a straight line, we have a line like a curve. The similar, this point is the anode point and this is the cathode point. So as the normal diode works in the forward bias direction, Zener diode works in the reverse bias direction, and the difference between the two is this line. How can we recognize Zener a diode? Now this is the symbol for a Zener diode. There is a black band which is the negative terminal, and the other one is the positive terminal. Then we have another type of the diode which is known as light emitting diodes. So LEDs or light emitting diodes operate in the forward bias direction. It emits light when connected in a circuit, and the following is the symbol for the LED. Now you can see there are two lights arrows which are going out of the anode. They represent that it is a light emitting diode, that is, the light is going out of the diode. That is why the arrow direction is towards out. So this side is the anode as previously, this is the cathode side as previously. How can we recognize an LED? The shorter LED of the LED is negative terminal and the longer one is the positive. You can see that there are two legs. The shorter leg indicates the negative one and the larger one indicates the positive one. Also on the negative side there is a flat spot when we see it from the top. So when we see from the top like this one, so there is a spot on the negative side, and we can see this is a shorter line, this is a longer line. So the longer line indicates the cathode line and the smaller one indicates the anode line. So and this is the diagram for an LED. As I have told you, the smaller one is the negative terminal, the longer one is the positive terminal. The mild steel lead frame soldier dipped leads, and this is flat on side of the dome indicating the cathode. Now this is an LED chip. The cathode post with reflector cup, you can see that on the cathode side we have this chip. On the anode side there is a wedge wire bond, and the whole structure is encapsulated in the form of glass, or simple as that, is acting like a small bulb. Now photodiode. Photodiode is actually known as a photodetector, and it is the opposite of the LED. As LED works in the forward bias direction, photodiode operates in the reverse bias direction. Now light goes out of the LED, whereas in the case of photodiode, light falls on the p-n junction of the photodiode, which creates electron hole pair in the depletion layer, which causes flow of current. Now where is the depletion layer? The depletion layer is present between p and n devices. So the current depends upon the light intensity. When light is incident on the photodiode, then current flows in the circuit. So as we have seen that the depletion region is actually present between the p and n, and which carries the electron hole pairs. So when the light falls, they break and they move and produce the current. So that current is actually the one which is flowing in the circuit because of the light. This is a physical view of the photodiode. So it is more or less similar to an LED, but the mechanism is opposite. Now this is the working of the photodiode. Now we can see that this is the basic biasing arrangement and construction of the photodiode. As it is visible, the arrows are now going towards the cathode. In the previous diagram, the arrows were coming out. So similarly, it is connected in the circuit with the resistor and the voltage applied. So when the light falls on this p-n junction, it generates the electron hole pairs which are broken, and they move in the form of the current, and therefore the current flows in the circuit. The last one is LDR, or light dependent resistor. A light dependent resistor is a semiconductor electrical device that has a very high resistance to the flow of electric current in the absence of light. So when light strikes the device, it lowers its resistance, allowing electrical current to flow through it and on to other devices of the electrical circuits. Now this is the basic arrangement of how LDR is connected. Similarly, LDR, you can see that there are 3 arrows. In the case of photodiode, we have 2 arrows. So this is the basic difference between the diagram. Similarly, there is a variable resistance connected in the symbol. This shows the LDR. Now the actual mechanism is because of the substrate, and it is a thin strip of photoresistive material, and we can see that there are 2 terminals coming out. One is for the anode and one is for the cathode. So this graph basically shows between the dark night time and the bright sunlight time that the illumination is decreasing. As from the dark night we move to the bright sunlight, and actually the cell resistance is decreasing. So the resistance which is given on the x-axis, on the y-axis, that is also dropping from 10 power 6 to 10 ohm as the time goes on. So LDR is basically because of resistance dependent. We can see that the resistance of the device is decreasing from the dark night time to the bright sunlight time, starting from 0.1 lux to 1000 lux. Lux is the basically unit of the light intensity. So that's all for the diodes. We will continue with the next topic in the next lecture. Thank you.